All right. Good morning, everyone. Sorry I can't be with you today. So today's lesson is going to be on the review of properties of logarithms. Should be a review from your Algebra 2 days last year. So just a quick review of your properties of logarithms. There is a multiplication property of logarithms, and let's first review the exponential property before we talk about the logarithmic property. Just a quick review. Remember, when you are multiplying like bases, the property of exponents is you're simply going to add your exponents together. So your logarithmic property states that if you're taking the log of a product, you can rewrite it as a sum. So you can break this logarithm up as log of A plus log of B. Remember, natural log is a logarithm of base B, so this also applies to your natural logs as well. Natural log of A times B is equal to the natural log of A plus natural log of B. You also have a division property of logarithms. Before we talk about the division property of logarithms, talk about your exponential property. Remember, when you're dividing like bases, you're going to subtract the exponents. You keep your base and you subtract the exponents. Your logarithmic property of division states that if you're taking the log of a quotient, you can rewrite it as a difference. So you can rewrite the log of A divided by B as log of A minus log of B. This is also a natural log of property. So you can take natural log of A divided by B and rewrite it as the natural log of A minus the natural log of B. You have a power to a power property of exponentials. Remember, you have a base of a power raised to a power. Remember, you're going to multiply those exponents together. Remember, when you're taking the log of a value raised to a power, you can rewrite it as a product by moving that exponent down to the front, so B times log of A. This is also a natural log property. So natural log of A raised to the B power is equivalent to B times natural log of A. So those should be some properties of logarithms that you talked about last year. Quick cautionary, there is no property involving addition. Just like when you add two variables together with different exponents, it is not equal to x raised to the a plus b. Same thing with your logarithms. If you're taking the log of a sum, it is not equal to log of a plus log of b. And obviously that would also apply to natural logs too. Same thing with your subtraction. In terms of your exponents, if you're subtracting x to the a minus x to the b, it is not equal to x to the a minus b power. Same thing with your logarithms. Log of a minus b is not equal to log of a minus log of b. Some other properties of logarithms that you need to be familiar with. Regardless of what your base of your logarithm is, log base a of 1 is always equal to 0. Because remember, a logarithm is just another way to write an exponential power because a to the 0 is 1. Log base a of a is just equal to 1. Remember, an exponential and log are inverses of one another. So if you have a raised to log base a, those are inverse properties, so they will cancel out just to give you n. Log base a of a to the r is just going to be equivalent to this particular exponent here. Log base a of 1 over n, again, using your division property logarithms, you can rewrite this as log base a of 1 minus log base a of n. And again, we know just from the other property up here in part A, log base a of 1 is 0. So 0 minus log base a of n is equal to negative log base a of n. If you have an equation where m is equal to n, you can take the log of both sides of the equation. So log of n is equal to log of n. Again, if you have an equation where you have log base a of n equal to log base a of n, then it has to be true in order for this equation to be equal. Then what's inside the logs also has to be equal to 1, then m is equal to n. You also have your change of base formula. So if you're trying to look at the log base a of b, you can change your base you can take a logarithm and change it into any base. So log base A of B. If you want to do the natural log, this would have to be equivalent to the natural log of B divided by the natural log of A. Your common logarithm is a logarithm, remember, with a base 10. But remember, we do not write, if it's a common logarithm, we do not write that base of 10. It's equivalent, we just say log of A. Any other base, you'll see the base written. So again, if you want to change a logarithm into base 10, you could simply write log of B divided by log of A.